All right, so let's start today's session. So good afternoon, everyone. My name is Jacob McDonald. I'm here with the Geographic Data Science Lab and the Consumer Data Research Center. So welcome to our Brown Bag seminar series. Just a few points of housekeeping before we jump in. So I'll ask that during today's talk, you keep your microphone on mute just to avoid any kind of radio feedback. There'll be time at the end for some question and answer discussions. So you're free to kind of unmute yourself during the discussion to kind of have that. On that note, feel free to use the chat and the kind of discussion in the bottom there to preempt any questions or points that you would like to bring up. So we can use that kind of to moderate the discussion at the end of the presentation. And as I mentioned, today's session will be recorded. So we are recording and we'll make this presentation available. So as mentioned, welcome all to the GDSL and CDRC Brown Bag seminar series. We're very pleased today to be hosting Dr. Mingshu Wang from the University of Glasgow. Dr. Wang is a senior lecturer of geospatial data science at the university, having previously held positions at the University of Twente as well. Generally speaking, his research looks at all aspects of urban systems and complex urban dynamics and urban modeling. So at kind of the more macro scale, some of his more recent research has looked at polycentric urban development and more polycentricity of different urban areas, local amenities and accessibility to different urban areas, or at the more kind of micro end of the scale, looking at transportation and human mobility and kind of the impact on very kind of localized dynamics. Today, we're really happy and pleased to have him talking about some really interesting novel research that he's been doing, looking at street imagery. So we're going to be looking at some novel image and data sources. And so on that note, I'll leave the discussions to the specifics on the research up to Dr. Wang. And just once again, we want to thank you, and I'll hand it over to you.
All right, so thank you, Jacob, for your introduction and also for the invitation. Actually, I have been a long friend with the lab. So the first time I visited the lab was like 6 years ago when I was a PhD student. I got the opportunity as an exchange student to visit the lab very briefly. So let me share my screen at the moment. Okay. All right. So today, I'm going to talk about one recent collaborative research regarding life between buildings from a street view image. What do big data analytics reveal about neighborhood organizational vitality? So yeah, my name is Mingshu Wang. I'm from University of Glasgow. Before we jump into the main content of today's presentation, I would like to acknowledge the following colleagues. Without their help, this work cannot be accomplished. First and foremost, Professor Floris Vermeulen from University of Amsterdam. He is also the co-author of this urban studies paper, which is that is today my presentation based upon. And also Professor Tony O'Sullivan, Professor Jon Bannister, as the editors of Urban Studies who provide constructive comments at the earlier version of the manuscript. Lastly but not least, Mr. Zhenglin Shi from the Computer Science Department of the University of Amsterdam, who provides us the computational resources. And also, we would like to acknowledge the Center for Urban Studies, Amsterdam Center for Urban History, Amsterdam Center for Cultural Heritage and Identity, to give us the opportunity and resources to support our study. So following a very traditional line, so today my presentation will be about a background of the study, literature review, from where that we kind of get our refutable hypothesis, data methods, results discussion, finally conclusions. So first thing first, about a little bit about the backgrounds. So why we are in particular interested in neighborhood-based social organizations? I think there are twofold reasons. First one is about social organization in general. The second one is more dive into the specific target, specific topic we are interested in, namely the neighborhood-based social organizations. Why we are interested in social organizations? Because they are important building blocks for our social life. Imagine that from our everyday life, social organizations, they just represent, connect, empower, and mobilize the residents within that neighborhood, within the community. And the neighborhood-based social organizations in this study, we are particularly interested in the organizations that provide specific leisure services for the neighborhood residents. And the reason for choosing that is it is just this kind of specific neighborhood-based social organizations that residents, they provide a very important role. They play a very important role in participating the organizational activities throughout their daily life. Some examples of this type of these social organizations include, like, say, sport clubs, cultural performance clubs, hobby associations, etc. And by saying the organizational vitality, what we really mean is, or what we really measure is the organizational survival rate. And by saying the built environment in this study, we are focusing on exclusively the neighborhoods in which an organization is located at very fine scale. Why we are interested in the relationship between built environment and the organizational vitality, that can be dated back to this seminal work of the Kevin Lynch, The Image of City. Basically, what Lynch argues is that given any city, okay, it can be regarded or can be imagined as a set of mental images by its residents. And each resident has its own imagination of the mental images. However, there are 5 elements of 5 qualities according to Lynch that is commonly represented or commonly shown in all these set of the mental images, namely the paths, the edges, the nodes, the districts, and the landmarks. Amongst these 5 qualities, paths are extremely important and interesting for this particular piece of work, because paths provide the foundation for an organization. And according to Lynch himself, that paths is actually the interconnection of the other 4 features. By saying path here, we include streets, sidewalks, trails, canals, railroads. And based on that, we argue that a neighborhood's urban design actually affect the social networks and social capital amongst the neighborhood. Some example like this, some infrastructure can enhance the residents' ability to engage in a collective action. However, there's some other types of infrastructure that may obstruct residents' ability to engage in a collaborative action. And another example is the workable neighborhood. If a neighborhood is indeed workable, it will inevitably increases trust, network formation, and social identity. So what we want to achieve for this particular piece of work are twofold. One is from the theoretical contribution. We want to contribute to the embeddedness of the non-profit and voluntary associations in a macro-institutional and ecological context that shape their organizational variability over time. So from an organizational perspective, what we want to achieve is we want to argue a simultaneously embeddedness in both the geographic context and organizational fields. And also what we want to argue or contribute is the neighborhood infrastructure might matter for organizations that have a very close connection with people just living in the neighborhood where the organization are located. And the second potential contribution we want to achieve is from methodological perspective. We want to explore the big data analytics to quantitatively examine the relationship between neighborhood level built environment and social behaviors. By doing that, we will incorporate machine learning and deep learning algorithms in conjunction with computer vision techniques. And what we also want to achieve is to scale up those individual level outcomes that been there for a while in this strand of research into a collaborative behavior, meaning the organizational behavior. So the next part is about the literature review. So we dive into the literature, and from the research gap, we formulate our refutable hypothesis, and then we use kind of our empirical strategy to test those hypotheses. So the first strand of literature we drew is the spatial dimensions of neighborhood-based organizations. From urban sociology theory of urban sociological research, we find that how local understanding of different forms of organizing amongst neighborhood residents may affect the availability of the organizational resources. In particular, we find stylized fact in the city of Amsterdam, by the way, which is our empirical study area. We found previously scholars have been researching and have revealed about the different demographical, the immigrants and children. They will affect the organizational survival rate in a different manner. However, from the traditional kind of the organizational studies literature, in particular the voluntary organizational study literature, we find there's a lack of tight link with the neighborhood constituency. So those strands of the literature tend to find there's no correlation between the presence of local neighborhood networks and the organization's ability to survive. And it also, those type of the literature tend to argue that the relationship between one type of the organization and the neighborhood is more structure or infrastructure. However, in this work, what we want to argue is that the organizations do have a tight link with people living in their surrounding areas. For instance, the voluntary leisure organizations, they create opportunities for local residents to enjoy their free time with each other. And the leisure organizations, as the most heterogeneous type of voluntary organizations, their members, you can imagine that they're coming from different social, demographic, and cultural background. And the second strand of the literature we relate ourselves is the workable neighborhoods and the social capital. So in the seminal work of the Death and Life of Great American City by Jane Jacobs, it essentially argues that cities for social interaction, the built environment character of the pavement, it's actually very important as they help create public spaces by bringing strangers together in a socially intimate proximity. And it is the informal interactions that encourage activities that which together create a collective sense of belonging. And a more recent seminal work by Yang 2011, namely the life between buildings using public space. It's kind of one of those followers from the ginjector theory. It argues that the built environment actually fosters this process by providing opportunities for low intensity, informal social interaction and information sharing. If we reflect on what these neighborhood-based social organizations do, essentially, they are creating low intensity informal social interaction indeed. And the Yang also argued that urban design that creates an accessible, attractive public space, and insofar as possible limits physical obstacles to the interactions. So based on that, there is a kind of new urbanism paradigm which essentially says that we should enhance the social capital by different means. And some examples are through the creation of pedestrian-friendly, walkable neighborhoods with easy access to parks, public transportation, and retail outlets. And a related concept to the workable neighborhood is what we call the mixed-use land and social capital. However, there are competing theories and for explaining the relationship between the mixed land use and the social capitals. So on the one hand, scholars argue that low level of mixed-use land is unconducive to neighborhood networks or a sense of belonging, because they only composed of residents offering very few service or public space, which can kind of spark connections between the residents. And because those neighborhoods are with low level of mixed land use, the daily needs are not locally filled. And because the residents encounter each other in an irregular way, and the neighborhood-based networks are not easily to be formulated or fostered. However, a competing theory also tells us a high level of the mixed land use may actually lead to high density of commercial enterprises, attracting people from outside the neighborhood. The presence of outsiders make it, however, more challenging to create a sense of neighborhood community, which in turn diminish the chances for the development of neighborhood-based networks. So at this moment, we found some research gaps. First and foremost, it's the opposite results from the subjective or objective measures when it comes to the correlationship or associationship between the mixed-use land and the sense of a community. And what we find in the previous literature is they are predominantly subjective measures throughout the field survey to get their kind of the first data. And there is a lack of the longitudinal studies, and there are some application of GIS layers. However, they are more kind of confined with crude proxies of the built environment, in particular in the sense of accessibility measures. Then what we think about is that how about we use the street level or street view images to get more granular information about the built environment. And the decision why we want to use street view images are showing on these slides. First and foremost, according to the theory and those seminal works, that streets are very important. It's actually is in the center for all kinds of human activities. Therefore, something related to the street should be included in delineating the built environment. And relatedly, what we find is that the street view image, it can simply provide a 360-degree panorama from the perspective of a pedestrian or a car on the street. So in a sense that it can mimic what a regular ordinary person or a car would do on the street. That is kind of semantically, or conceptually, it's completely different from the data that we get from the satellites, remote sensing or airborne remote sensing images. And the last thing is about the data availability issues. There is a growing kind of the product variability and also the global coverage of this particular type of the data. And from a literature review perspective, we summarize currently there are 3 strands of the application of street view images for urban studies. One is that it's just a replacement for the visit to the sites because relatively they are low cost, time efficient, and user friendly. And they provide a very powerful tool, especially in the situation that the official statistics are not available or not accessible by the researcher. And the second strand of the empirical work is more populated by the GI scientists, and we are keen on extracting built environmental composition automatically or semi-automatically from the machine learning and computer vision algorithms. And also some scholars take one step further to quantify the human perception, which were not easily quantifiable previously. And a third strand of the literature has been focused on the kind of establishing the relationship between street view derived measures versus individual level of outcome, such as the health, crime, etc. So within that, we have formulated our refutable hypothesis in these slides. So basically, what we argue in hypothesis number 1 is the presence of car or trucks or basically car-related infrastructure in an organization's proximity will decrease the likelihood of its survival. And hypothesis number 2 says that the presence of pedestrian and working related infrastructure in the proximity of an organization will actually increase the likelihood of its survival. And we have 2 competing hypotheses, namely hypothesis 3A and 3B. While 3A says the presence of the mixed use land in an organization's proximity will increase the likelihood of its survival. The hypothesis number 3B, we also frame it as the outsider or stranger focused hypothesis, which essentially says that the presence of the mixed use land in an organization's proximity will decrease the likelihood of its survival rate. With the this refutable hypothesis, the next steps is we are going to gather data and establish our empirical strategy. So the study area and the data, what we got is we got these organization data from the city council of the city of Amsterdam. Basically, we collect 15 years of the data, which include basically the foundation year, the name, the address, the mission statement, the board member's name, country, and day of birth for each of those organizations. And because we have the full data sets of all kinds of the voluntary organizations, so then we subset the data to extract the neighborhood-based leisure organizations in particular, because this is a major focus of this study. And those organizations can be broadly categorized into sports club, like cultural performance clubs, hobbies association, and the other type of the organizational types. And we use Google's API, both for the geocoding and for collecting the Google Street View images. Basically, we have 4 scenes per location. And the next step is to extract the built environment features from the Google Street View panoramas. In this study, we just used a pre-trained model called DeepLab version 3+. And because at the time of the experiment, that particular algorithm represented the industry standard, and it performs very well against different benchmark data sets. For that simple reason, we just use that one. And what we were particularly interested are the group of the kind of the features that belongs to car-related infrastructure, pedestrian-related infrastructure, and other type of the built environment features. So for the car-related infrastructure, it may be road, traffic sign, car, trucks, bus. For the pedestrian-related infrastructure, it includes pavements, terrain, and people. And in order to get the mixed use land, we kind of combine the color analysis and the Celium region extraction. So for the color analysis, what we operationalized was the 2 variables. One is the first color proportion, and the other one is the number of the major colors. Our assumption is that the higher the value of the kind of the first color proportion, that it shows a lower level of a mixed use land. Basically, it may infer that the built environment is predominantly occupied by one single type of the kind of the function. And the number of colors, the higher the number of the major colors, and we assume that it will have a higher level of mixed use land. The other variable we got is the Celium region ratio. That is a Celium region usually referred to spaces with some semantic contents. It usually are those foreground features, no matter they are mobile or immobile features. And this is a very classical computer vision algorithm. It can be easily implemented and is very efficient in Python, R, MATLAB, you name it. So what we got is the Celium region ratio. Basically, the lower, we assume the lower the value is, the more background feature is, the higher level of the, or higher likelihood of the mixed use land. And the last set of the variables are those organizational level control variables. This is kind of, these just follow the standard of the voluntary organizational studies. They must have control variables in their empirical work, namely the organizational age and the association, and whether or not a organization has overlapping board membership with other organizations, whether or not it is located in the city center of Amsterdam, and the type, the category, the different category of the particular organization. And in terms of the empirical strategy, we decided to use penalized regression for their kind of the simple implementation and for its efficiency. And the penalized regression, some people also refer it as a shrinkage or regularization methods. Basically, it discourages complexity by penalize if you have too many variables in a model. And basically, it adds a constant to equation to reduce the coefficient values towards 0. So that's by doing so, it has the functionality to have less contributive variable to have a very small coefficient. And sometimes it can help solve the overfitting problems. And the literature recommends when there is a large number of variables, when the ratio between the number of observations and the variable is low, and when variables are highly correlated, it is recommended to use penalized regressions. Some examples of this regression family includes the ridge regression, lasso regression, elastic net regression. The difference between the ridge regression and lasso regression is the former one. It adds the square of the magnitude of coefficient as a penalty. And the later one, it adds the absolute value of the magnitude of coefficient as a penalty. And so there are some more detailed and nuanced difference between the ridge regression and lasso regression, and in terms of their strengths and weakness. But in the end, we decided to use a elastic net regression, which essentially is a combination of both ridge regression and lasso regression. And following the machine learning practice standard, we divided our full sample into the training sets, which consume 70% of the data with tenfold cross-validation, and also 30% of the data, or we use them as the testing set, as the kind of the testing sample. Now let's jump to the results and the discussion part. So first thing about our hypothesis number one is about the correlated building environmental features. What we found is the abundance of the traffic sign, trucks, and roads correlated with a higher likelihood that a voluntary leisure organization will be disbanded, and the abundance of buses correlated with a higher likelihood of the organizational survival. And if we are looking at the magnitude of the beta coefficient, what we can easily find is the bus perhaps is the most influential predictor of the organization survival. And the bus is a proxy for the availability and accessibility of the public transportation. And when it comes to the hypothesis number two about the pedestrian-related building environmental features, what we find is the presence of people, terrain, and the pavement are associated with kind of higher likelihood of the organizational survival. And people, let's say the pedestrians, they are direct measure for urban vibrancy by a number of different literature. And the terrains here are indeed composed of urban green spaces, pavement. And what Linden said or refer as the traditional neighborhood, which is the mix of people and the urban green spaces. And from this batch of the kind of the results, we can see that the predictive power of the pedestrians is stronger than those of the pedestrian-friendly infrastructure. And other built environmental features, what we find is the riders, by the way, riders are the people who are riding the bicycles. So that's the mechanism of that, we argue that is similar to the presence of the people. And both the riders and pedestrians are direct evidence of the vitality. And what we find also the presence of the poles here are predominantly straight lines, are associated with higher likelihood of organizational survival. And the straight lines are usually represent a proxy for the sense of urban safety. And also the presence of the fence, the abundance of fence, which are oftentimes represented by urban parks, are associated with higher likelihood of the organizational survival. And in terms of the mixed-use land features, what we found is, first of all, what we found is the mixed-use land, it actually increased the likelihood of organizational survival. However, a higher Celium, on the one hand, higher Celium region ratio shows a lack of background built environment features. The higher the value of that, kind of the higher probability it is for a organization to be disbanded. However, from the color analysis, we find kind of sort of the counterintuitive or competing results. On the one hand, what we realize is that the higher the kind of the major color, the predominant color is, the less likelihood the organization is disbanded. However, at the same time, we also find the more number of major colors that the organization is also less likely to be disbanded. One possible explanation would be that the urban designers kind of the personal color choice plays the role in terms of the urban neighborhood design or building environment design to a no kind of trivial extent. And what we find that it's, however, if we compare the magnitude of the coefficients in this group, it has much less predicting power compared to the car-related building environment features or pedestrian-related building environment features. And for the results of the organizational level characteristics, they are generally consistent with the previous organizational studies literature. For instance, sports clubs are less likely to be disbanded. Organizations that are association, foundation, interlocked, or located in city center are less likely to be disbanded. We also kind of reconfirm a weak sign of the liability of newness, meaning that the age of an organization, it influences survival rate in a nonlinear way, which is basically an inverted U shape. And all those surviving organizations have been there at least for 15 years. With that, so there are some caveats and limitations of the studies that we have to call out. First and foremost thing is about the address. We get the organization address from the city government of the Amsterdam, basically their chamber of commerce. And those address, the only address we can get is their registration address, which may or may not be the actual location where those activities are happening. However, given the small scale of these neighborhood-based social organizations, most of them where they register are the places where those activities will be take part in. And the second one is that because Google recently revised their terms and conditions, what we can get, the best we can get is only the most recent available Google Street View images. Kind of a consequence for that is we are using a more current Google Street View images to predict organization survival for the 15 years. And based on some organizational level characteristics of the organization back to 15 years. And also we have to admit that for the Google Street View images, even in the city of Amsterdam, there is a huge difference in how often or how frequent they update their data in different areas of the city, both spatially and temporally. So let's jump to the conclusions. So what we did is we looked at the extent to which the built environment impact the survival rate of neighborhood-based social organizations. we explore how different elements of building environments that encourage working will increase survival rates of the organization. We also targeted at how different elements that discourage working by encouraging heavy car use can potentially decrease the survival rates of organization. We also find the mixed-use land has a positive, however less strong, effect on the survival rates of neighborhood organizations. And the implication for all of that, we try to contribute to the literature when it comes to urban or neighborhood design, that we want to reiterate the importance of the accommodation of the pedestrians. And for the ways forward of future work, what we reflect on the methodological part is the availability of street view services is a good alternative data source for quantitative urban studies. And the application of deep learning and computer vision algorithms can effectively and efficiently give us some additional information. And the combination of street view images and the machine learning type of the algorithm can often provide us a fine resolution information at very low cost. And also, often of times, this data are potentially globally available so that the international comparison becomes kind of more accessible. And we also highlight the use of elastic net regression. In some situations, they can be an effective alternative to the traditional OLS regressions. And last thing but not the least is what we reflect on the topic why we are trying to tackle the organizational vitality issue with the big data urban analytic methods is that the combination of the data and the computational methods will probably give us a new opportunity to reassess and extend the understanding in previously unachievable way. That is our kind of our takeaway message from this particular piece of scholarship. So that's all for my presentation today. And before we jump into the Q&A, I would like to use this opportunity to share two advertisements from my school. One is that we are hiring, that we have two openings on our postdoc fellowship. One is focused on the geostatistics. The other one is more about the cross-source data and signal processing. Both of them are due within a week, so there is still plenty of time. The second one is basically two students studentship. One is the Scottish Graduate School Social Science. There is anyone can apply for it. The other one is more tailored to the Chinese citizens. If you are interested in doing the next round of China Scholarship Council, feel free to check out the website, and because there's some house rules for the College of Science and Engineering within the University of Glasgow. Okay, that's all for my presentation. Thank you for your listening.
Thank you. That was a really interesting talk and discussion. So yeah, we have some time there. The chat is there if people want to kind of put questions in the chat, feel free, but also feel free to just kind of unmute yourself and come forward if you have any specific questions that you want to bring up. If not, I can start off. I had a question about, so you control for a lot of different variables, obviously, in your study, and you're drawing from a lot of Google Street images and, you know, creating different measures. You control for kind of traditional, you know, neighborhood census variables, for example, and, you know, population demographic distributions and that. And what's your kind of view for the extent to which this like novel forms of data can complement or substitute some of these more, administrative census data, which, maybe be 10 years old, but, at least you get kind of population densities and distributions and demographics.
Yeah, so that's actually a very good question. So, and this is some question that I've been thinking, yeah, for a while. I don't have a definitive answer at the moment, but I'm trying to answer. So, in my opinion, we are not targeting or aiming for replacing or substituting the traditional census data with the new form of data or street level images for a number of reasons. And the reason for that is the kind of the data collection mechanism, the data collection, the framework are more homogeneous, are consistent throughout the time for the census data. And there are some information that is extremely valuable at the neighborhood or at the census tract level that we don't need or we don't have to reinvent the wheel to use kind of the alternative source to tackle that. However, what kind of new form of data, in particular of the street view images in this case, is that it can complement or it can play a role where the granularity of the census data are not there. So, for instance, a number of the social demographic variables are given at the polygon, whatever the polygon it is, at the zip codes or at the census tract at that level. And and what we really want to do in this particular work is we want to see that how about the very close proximity of the organization, as if that's when you're standing in front of the organization, what you can see just by turning around, what you can see, how would that make a difference in the organization's survival rate? And in order to answer that type of the question, the traditional census tract data information cannot give a kind of a accurate proxy for that. For that particular reason, we decided to use Google Street View images. So long story short, I think both data have their strengths, and probably the best thing is to we pull the strengths of different data.
I have a few questions in the chat, so I'll jump. Danny can't jump on voice, so I'll ask the question for him. But he said, can you give us a sense of the difficulties and challenges encountered in using computer vision? The main issues, whether it's finding, a machine that's big enough, the computational powers, getting to grips with the concepts, the programming, et cetera, et cetera.
Okay, thank you, Danny's question. So actually, there are a number of the questions. I think the difficulties and the challenges that I encounter using computer vision algorithms, and main issues, there are a number of them. First thing is about the interpretability, that there are different algorithms for the computer vision, and follow this particular kind of the streamline, you can get the results. And the question is actually the interconnection, the connection within the urban studies, within the knowledge domain. That's what does this algorithm, what does the treatment, what does the procedure of this computer vision algorithm, what does really mean? What does that actually do in terms of getting the built environment characteristics, like in this study? And it's more about how we can interpret, how we can use and to conceptualize or contextualize the algorithm in the problem domain. And that is, I think, the first and the foremost issue. And the other thing is I have to admit that the machine kind of the computational power is really a thing that for the applying for the Deep Lab V version 3 plus algorithm, I first tried to using my laptop. It's about 1 minute per thing. And then I tried to use my desktop. It's like 10 or to 20 images per thing. And finally, I decided to give up and to seek for the kind of the computational power of the cluster for the computation, of which process all of the data within half a day. So this, I think, the accessibility of the powerful machine is also another issue. But at the same time, I'll see, because Google has its the TPU units, I believe that there are more and more kind of the online-based, cloud-based powerful computers that can actually help us in the situation that we do not have access to the clusters or like the supercomputers. Yeah, I think.
Oh, go ahead.
Yeah, I think that's, basically the difficulties, challenges based from the contextualization of the computer vision algorithms to the urban context and the limitations of the computational power. I think both I face challenges.
Bob, I don't know, you want to just jump in right away, or do you want me to?
Yes, I'm happy to do it. No, I'm happy to do that. Thank you for a very interesting talk. We're in an unusual position, UK, because we've got this really peculiar artifact, Ordnance Survey Master Map, which is a very highly structured map, much more structured than most multi-purpose cadasters, and with a lot of good building detail on it. Have you considered using Master Map and Street View together so that building attributes extracted from Street View can be attached to Master Map buildings?
So thanks for Bob to bring up this data. The kind of the data set. Assume that the master map is something that's particular to UK context, right? So it's not.
That's right. GB even, not even UK, because Northern Ireland is not included.
Okay, so it's only Great Britain.
Afraid so.
Okay. So I think, I'm going to answer the question in this following way. So first, I admit that using the multiple data sources and to pulling information from other directions, including master maps, which have the kind of detailed building plan, etc., will increase the predictive power of the model. That is for sure, and I'm confident for that by adding different information, more data, more kind of the more powerful algorithm, we will achieve better prediction results. That's for sure. That's for sure something that we can improve. At the second time, that the purpose of our current work, the work I'm presenting, is indeed more about to explore the ways that the street level image, if and to what extent the street level image can contribute to quantitative urban studies. For that simple reason, what we have in the current model is those must-have variables as the control variables in the organizational studies, plus all other informations only coming from the street level images. So for that particular reason, it was kind of we deliberately kind of narrowed down our focus data sets in within the kind of remit of the Google Street View. But
okay, thank you very much.
There's also a question from Stephen Law. I don't know if you want to jump in and ask yourself, or I'm happy to read it out as well.
Okay, let me see. Yeah, I can read out the chat.
Yeah, I can ask as well.
Okay.
I mean, so some of the street view predictors could be correlated to the location of a place. So for example, larger roads would be in less accessible space in the city, and smaller roads would be more accessible space. So have you thought about have you considered this effects, or have you thought about how we could disentangle between the two, just to get more meaning, I think, behind these predictors? Yeah, thank you.
Yeah, that's a very nice question, actually. So, so first, as I mentioned, that we use the pre-trained model, and that confines on what we can do with it. So, the classes we have and the kind of the maximum categories of the built environment features we can get are kind of predominantly defined by the pre-trained model. This is if I got a chance or got the resources to redo it, probably we will need to kind of relabel, kind of labeling those kind of the classes ourselves. We may want to annotate it as samples ourselves, but given that the potential correlation of different classes of different features of the built environment, one way we deal with that was the use of the penalized regression model. That's to give us a balance in a way that it's a linear model. It's easily to be interpreted. At the same time, it can handle kind of the multicollinearity to some extent.
Thank you, Wang.
And Francisco, do you want to ask yours, or I'm happy to as well?
Yeah, I can do it. Thank you for that presentation, really interesting. So I was just wondering, given that we experienced something similar to what you seem to have experienced, which is this change of terms in the use of data by Google. And that got me wondering whether you have identified any alternative data sources that may have comparable attributes in terms of geographical coverage, for example.
Okay, yeah, that's something the OpenStreetMap community, that's as far as I know, the OpenStreetMap community has launched the OpenStreetView, I think, or similar. I don't remember exactly on top of the head. It's some similar, how it works is similar to how OpenStreetMap works. It's a cross-source based platform that asks people to upload the cross-source version of the street level images, but the kind of implication, the consequences, or caveats are similar of those road network or different building data that's coming from the OpenStreetMap. The other kind of alternatives I have been aware of is the Mapiller. That is perhaps another source of the street level images. However, Google claims it has the most extensive global coverage, and all these alternatives and the kind of competitors are not really their competitors.
Yeah, thank you.
I was also wondering, Mingshu, what extent do you think that this could be replicated for other types of, non-profit amenities. So I'm thinking, retail centers or parks, or, classifying the built environment, and, would have kind of important consequences for a range of different types of amenities, openings and closing dynamics.
Yeah, so basically, I think essentially from the theoretical perspective, all the literature we draw upon are the social capital ones. That's where we argue is that the built environment, there are some particular characteristics of some type of the built environment can create social capital or can stimulate the social capital, so that the organization that in this case, the neighborhood-based or kind of the voluntary neighborhood-based leisure organizations, they rely heavily on the accumulation at the level of social capital to be successful. And if we continue this line, that's I think the framework can be expanded and replicated by any case that the kind of the terms of kind of the target or the subject of investigation relies heavily on the social capital. For instance, like the prosperity of the coffee shop and the kind of the pubs, the restaurants, the street foods, the chain of street food, and even commercial centers, where that not necessarily the commercial center, but some kind of the mixed use, the building plaza, essentially where that the success of those places, those firms or the locations are heavily kind of dependent on the accumulation of the social capitals. Yeah, this is something I can think of.
Yeah, I can see a lot of uses for this kind of stuff moving forward, especially if we can kind of reduce the barriers and the computational limitations that you spoke about. If we can make this more accessible, then this type of research and this type of data has a kind of a big future for sure. So we have, a little time for any last minute questions or comments, if there's any. If not, like you said, you're accessible. So anyone from the lab, you left your contact information in that. So feel free to get in touch with Mingshu. And if there's no other last minute questions or comments, then what I will do, I'll just take this opportunity to thank you once again for joining us. This was a really interesting presentation, really nice discussion. I think, we all kind of learned a lot about these new data sources and the applications. So thanks for joining us, and we'll be looking out for future research in this area.
Okay, thank you. Thank you for your time.
Thank you all.